Hey guys, today I have decibel meters or dB meters as they are commonly referred to. The question is, which one among these is accurate when you're taking measurement? The answer is we don't know. We don't know which one is accurate between these two, and that's what we are going to test and find out if any of these is actually closer to the true value, and if all of them are inaccurate, what do we do to correct that or kind of standardize them so that the reading is as accurate as it should be? So let's start, and we're going to play pink noise. It's a standardized noise that is a kind of broadband, to see how this one responds to that noise and compare that difference, and then use a calibration equipment to test which one is actually more closer to accuracy between the two. So let's start by playing the pink noise, and then we see how this goes. So I'm going to play the pink noise just right now. So one reads 74, the other one reads almost 77. There's a difference of 3 dB, which is very huge. That's a massive difference. So which one among these is accurate? So for us to get the accurate one, let's find the calibration equipment and see how each one of these performs. So this is the calibration equipment, and if you look at it here, I don't know if that's, yeah, you can see it has 94 dB reading and it has 114 dB reading. And what happens is that there's a small hole here. This is where you place the microphone capsule inside here, so that it can read the noise level that is being generated here. This is, I think, 1 kilohertz of noise at 94 dB inside here. So let's place it here and see if this one will read 94 dB. If it doesn't, then the difference is what we need to add or minus to ensure this one reads as accurate as it should. So let's switch it on. So this one reads 94.9. So when you're taking measurements, we need to minus 9 so that we correct that difference in readings. So let's test with this big one and see. So I'm going to activate the 94 dB reading and place it here and see if it's giving us 94. If it's giving us 94 without any addition, then that means this is more accurate. If it has any difference, then that is what we add or minus to be able to get the correct readings as required. So let's do this. Let's switch it on at 94 dB. So you can see this is pretty accurate because it's 94 dB. 94 dB. There's a tone that is ringing here very loudly at 1k kilohertz, and that is what we use to calibrate this one. So at 94 dB activated, as you can see here, 94 dB is activated, and that is what is showing here. This means this is close to class 1 or class A sensitivity in when it's come to reading of the data or the noise levels. So that is how you test. You need to have this calibrator to give you the exact level of reading when you are taking SPL measurement.